Right now, the internet is fiercely debating whether artificial intelligence is going to steal jobs from graphic designers or, copywriters and video editors.
Oh, yeah. Everyone is obsessed with chatbots writing poetry.
Right, exactly. But while everyone has been staring at their screens, heavy industry just kind of quietly handed over the physical keys to the factory floor.
They really did.
I mean, multi-ton autonomous agents are officially escaping the screen. So welcome to the deep dive.
Glad to be here.
Our mission today is to unpack this massive shift that was detailed in Deloitte's Tech Trends 2026 report. We're looking at how organizations are finally breaking out of what they call pilot purgatory and stepping into real-world impact.
Yeah, the experimentation phase is basically over.
It is. So I want you to take a second and visualize a modern smart factory. I'm not talking about a traditional human assembly line, right? And I'm definitely not talking about those early automated factories where a robotic arm just swings back and forth on a rigid loop.
Right, the old pre-programmed stuff.
Exactly. Walk onto one of these new floors, and there are no fixed conveyor belts. Instead, there's just the synchronized hum. Machines are, seamlessly moving around each other, dynamically adjusting routes, and physically collaborating.
And the environment you're describing, well, it's a total paradigm shift. Because intelligence is no longer just a software program running on a server somewhere in a distant data center.
Right.
The intelligence is embedded directly into the physical hardware itself. We're looking at multimodal AI models plugged straight into robotic chassis.
Which is wild to think about.
It is. But to really grasp the magnitude of this shift into physical space, we first have to understand the sheer, unprecedented velocity of adoption driving it.
Yeah, the speed is what gets me.
We are watching the complete compression of what economists call the S-curves of innovation. Historically, the gap between an emerging technology being invented and it becoming mainstream reality, it was long enough for a business to comfortably adapt.
Right. I was looking at the timeline comparisons in the Deloitte report, and they are genuinely staggering. To give you some context, the telephone took 50 years to reach 50 million users.
50 years.
Yeah. And the internet took 7 years to hit that same milestone. But a leading generative AI tool, it reached 100 million users in about 2 months.
It's just absurd.
And as of late 2025, that single tool has over 800 million weekly users. I mean, that is roughly 10% of the entire human population using an emerging tech every week.
And that user adoption rate is, well, it's merely the surface metric. What's actually fueling this timeline compression is a really powerful flywheel effect.
Okay, unpack that flywheel for me.
So we're used to technological forces adding up sequentially, right? Now they're multiplying. A breakthrough in foundational models enable, say, 100 new software applications.
Right.
Those applications immediately generate a massive influx of novel data. That new data attracts billions in venture capital, which build highly specialized hardware and infrastructure.
Which then drops the cost of everything.
Exactly. That infrastructure suddenly drops the computing cost, which triggers a wave of even broader experimentation by smaller companies. And that leads to the next breakthrough. Every single turn of the wheel reduces the friction for the next turn.
Okay, let's unpack this a bit more, because it sounds like, businesses are being asked to swap out a car's engine while driving 100 miles per hour.
That's a perfect analogy.
There's actually a quote in the source material from a chief information officer that gets right to the heart of this. They said the time it takes their enterprise to study a new technology now actually exceeds that technology's relevance window.
Yeah, the half-life of knowledge is basically measured in months now.
Right. If you're an executive trying to manage a global supply chain, what do you even do with that reality? How do you operate when your risk assessment outlives the tech you're assessing?
Well, the traditional corporate playbook assumed you had the luxury of time. Run a small pilot, analyze the results for a year, form a committee.
And gradually roll it out.
Exactly. But organizations built for that kind of sequential improvement simply cannot compete with competitors operating in these continuous high-speed learning loops. Survival now requires moving from a capability-first mindset.
Like asking what a shiny new tech can do.
Right. Moving from that to a need-first mindset. You have to isolate your biggest operational bottleneck and just deploy whatever combination of agents and hardware will solve it today, even knowing you'll probably swap out the underlying tech again in a year.
Wow. So because of this massive flywheel, this explosive intelligence, it's generating so much actionable data that it literally cannot be contained in a digital dashboard anymore.
No, it's outgrown the screen entirely.
Right. A dashboard can tell a manager that a warehouse is inefficient, But the AI is now smart enough to fix the inefficiency itself, and that forces companies to put that brain into a physical body to execute the actions.
Yeah, look at Amazon as a prime indicator of this shift. They recently crossed this massive milestone of deploying their 1 millionth robot.
1 million robots, that's insane.
But the hardware isn't the real story here. The orchestration is. They utilize a system called Deep Fleet AI. Instead of each robot operating as an isolated unit, Deep Fleet acts as a collective swarm intelligence.
Oh, like a hive mind.
Exactly. The robots are communicating their coordinates, their speed, their loads in milliseconds. They're negotiating right away before a bottleneck even has a chance to form. By mapping those routes globally, they improve travel efficiency within their warehouses by 10%.
And 10% across a logistics network the size of Amazon's. That translates to a staggering amount of saved time and capital.
Absolutely massive.
And it isn't just logistics, right? In heavy manufacturing, BMW's factories now feature cars that are literally driving themselves through kilometer-long production routes.
Yeah, they don't rely on human drivers shuffling the chassis from one station to the next anymore.
Right. The product itself is acting as an autonomous agent participating in its own manufacture. Let's compare the mechanics of this, because 10 years ago, a warehouse robot followed a literal painted line or a magnetic strip on the floor.
Yeah, the old rigid tracks.
Exactly. And if a pallet fell in its path, the robot just stopped and beeped until a human came to move the box. It was automated, but it was basically blind. Today, we're dealing with spatial AI.
And spatial AI completely changes the fundamental geometry of the factory floor. The robot is no longer relying on hard-coded physical infrastructure.
What's it doing instead?
Well, it's using raw camera feeds and LiDAR pulses to create a mathematical, three-dimensional semantic grid. It doesn't just see an obstacle. It understands that this cluster of pixels represents a human leg, while this other cluster represents a cardboard box.
Oh, wow. So it knows what it's looking at.
Right. It calculates the physical dimensions, leverages predictive physics to assume the human might move, recalculates a bypass route around the box, and instantly updates the shared cloud network.
So every other robot in the facility knows the obstruction is there.
Exactly.
I mean, I'm listening to this description of machines silently negotiating routes and updating global spatial maps, but my mind immediately goes straight to the digital chatbots we use every day.
Oh, the hallucinations.
Yes, they hallucinate. They confidently invent facts out of thin air. Now, if a digital chatbot hallucinates the date in an email, it's embarrassing, maybe a bit frustrating.
Sure.
But if a 2-ton autonomous forklift hallucinating its spatial coordinates decides to drive straight through a structural pillar, or worse, a group of workers, people get hurt. How do you trust a large language model with real-world physics?
That tension between digital flexibility and physical consequence is it's the central challenge of embodied AI.
Right.
In a purely digital workflow, you can tolerate a margin of error.
Right.
But in a factory environment, safety has to be deterministic. An autonomous forklift cannot afford a software glitch. So to handle this, engineers do not rely on a single text-based language model.
Right.
They employ multimodal systems constrained by physical edge computing.
Edge computing meaning it happens right on the device.
Exactly. The safety parameters, the laws of physics, and the emergency stop protocols, they're baked directly into the silicon on the device itself. The machine does not have to send a signal to a cloud server in another state and wait for permission to stop when a human steps in front of it.
Oh, thank goodness.
Yeah, the inference happens instantaneously on the edge.
So the local hardware physically prevents the AI from violating the laws of gravity or safety, regardless of what the broader network suggests.
Right, it's a hard stop.
But, if these edge-constrained agents are successfully driving cars off assembly lines and optimizing warehouses without human intervention, it brings up a very visceral question. What happens to the human workforce?
The big labor debate.
Yeah. Are we looking at the final death knell for blue-collar manufacturing, or is the reality something entirely different?
Well, the transition is much more complex than simple job replacement. And the current data reveals a fascinating, really sobering reality. Gartner projects that 40% of agentic AI projects will fail by 2027.
Wait, really? A 40% failure rate?
Yep. Despite the massive capital investment and the incredible sophistication of the models, only 11% of organizations actually have these autonomous agents fully functioning in production right now.
That makes no sense. If the swarm intelligence is this advanced and the spatial mapping is this precise, a near half failure rate is crazy.
Yeah.
What is breaking down between the brilliant software and the physical floor?
To understand the breakdown, we need to clearly define what an agentic AI actually is. Because an agent is not just a tool that answers a question.
Right, it's not just a chatbot.
Exactly. It's an AI given a broad goal, like clear this shipping backlog, and it can autonomously plan, access databases, and execute multi-step workflows to achieve that goal.
Okay.
The failure occurs because companies are taking these brilliant autonomous agents and forcing them to operate inside deeply broken legacy processes.
Oh, here's where it gets really interesting. It's like automating a bad process is like putting a jet engine on horse-drawn carriage. It just crashes faster.
Where? Yes. Or it's like discovering a brilliant chess prodigy, sitting them down at a board and telling them they're only allowed to move their pawns one space at a time.
The intelligence is fully there, but you've constrained it within an outdated framework, so the whole system just hits a wall.
That captures the structural mistake perfectly. Companies are merely executing inefficiencies at machine speed.
So how do they fix it?
The Deloitte report highlights a strategy from the chief financial officer at Hewlett-Packard Enterprise that specifically addresses this trap. Their approach mandates selecting entire end-to-end processes for total transformation.
So you can't just patch a single pain point in a logistics chain.
Exactly. You have to completely redesign the operation from the ground up to utilize the specific capabilities of the agent. You can't just force the silicon worker to mimic a human workflow that was designed in 1995.
Right, but if we're redesigning the entire workflow so agents don't have to act like humans, what becomes of the actual humans on the floor? Does the future worker evolve into a sort of, I don't know, robotics whisperer?
Actually, Deloitte frames this workforce evolution as the Great Rebuild. The organizations pulling ahead are not aiming for the total eradication of the human worker. They are architecting environments where humans and agents work in an orchestrated tandem.
So the human role elevates.
Yeah, it moves from manual, repetitive execution to strategic oversight, exception handling, and complex problem solving that machines still struggle with.
There is a case study in the report about Walmart that illustrates how to navigate this human-agent integration really well. They needed to deploy a new AI-powered scheduling application for their 1.5 million store associates.
Right, a massive rollout.
Huge. And historically, a company would put a dozen engineers in a room to build a tool and then just mandate that the frontline workers use it. But Walmart built the tool with the associates.
Which is key.
Yeah. They designed it to enable shift swapping, provide deep schedule visibility, and basically put agency directly back into the hands of the human worker.
And the adoption metrics from that project are the ultimate proof of concept. Because the tech was designed to empower the worker rather than just, extract efficiency from them. The time managers spent on scheduling dropped from 90 minutes down to 30 minutes.
Wow. From 90 to 30.
Yeah. And the employees organically adopted the tool because it solved their immediate problems. It highlights the profound difference between imposing automation on a workforce and integrating autonomy into a workforce.
That makes total sense. When you hand someone a tool that makes their day harder, they will inevitably find a way to break it, ignore it, or bypass it entirely.
Oh, 100%.
But when you empower them to orchestrate the technology, they become the linchpin of your operations.
Right.
But, distributing all of these physical robots, agentic workflows, and human-agent interfaces creates an invisible IT nightmare. We have to look at the sheer scale of computing power required to keep this synchronized hum from grinding to a halt, which the report refers to as inference economics.
Yeah. Inference economics. The underlying mathematics of AI computing are shifting rapidly. The computational cost to process a single piece of data, a token, has plummeted roughly 280-fold over the past 2 years.
280-fold on paper, that sounds incredibly advantageous for enterprise scaling.
It does sound great.
But the unit cost might be pennies on the dollar, while the volume of computation required to run a fleet of spatial AI robots, negotiating millisecond right-of-ways, is astronomical. The report notes that some enterprises are quietly getting hit with monthly cloud computing bills in the tens of millions of dollars.
Yeah, it's a huge shock.
Imagine getting a surprise $10 million cloud bill simply because your autonomous warehouse was a little too efficient with its computing.
Exactly. And that kind of financial volatility is forcing a complete restructuring of enterprise architecture. Because for the last decade, the universal mandate was cloud first.
Right, migrate everything to the cloud.
Yeah, the goal was to put every single asset on centralized cloud servers. But a purely cloud-first infrastructure was never designed to economically scale physical AI deployments. The bandwidth costs and the latency are simply too high.
So what's the alternative?
Well, consequently, organizations are abandoning the cloud-first dogma in favor of a strategic hybrid model.
Okay, so how does a strategic hybrid model actually function when you are managing a physical factory floor? Like, what goes where?
You partition the intelligence based on its function. You retain the cloud for its elasticity, using it to train the massive foundational models and process historical data trends.
Makes sense.
Then you utilize localized on-premises servers to handle your baseline, predictable workloads, which stabilizes your operational costs. And critically, you deploy edge computing directly onto the robots and sensors for immediacy.
Got it. So the heavy lifting happens in the cloud, but the split-second spatial decisions happen on the machine itself. But by pushing all of that decision-making capability out of a secure, centralized server room and onto thousands of moving devices, you're massively expanding your attack surface. You no longer have a single fortress to protect. You have an army of autonomous moving targets. How do you even begin to secure a decentralized physical AI network?
Well, the cyber reality of this transition is perhaps the most formidable hurdle. The Chief Information Security Officer of AT&T provided a very stark assessment of the landscape here.
What do they say?
They pointed out that the foundational motivations of cyber threats haven't changed. Bad actors still want to infiltrate systems, steal proprietary data, disrupt physical operations, and extort ransoms.
Sure, the usual suspects.
Right. But what artificial intelligence changes is the speed and the catastrophic potential of the impact.
Oh, so it's the multiplicative flywheel effect, but applied directly to cybercrime.
Exactly that. Threat actors are deploying AI agents to probe networks for vulnerabilities thousands of times a second. And in a physical environment, an attack might not be an obvious shutdown.
What would it look like?
It could be an AI subtly altering the spatial parameters of a warehouse fleet, inducing micro-collisions or routing errors that degrade overall throughput by, say, 5%.
Wow. So it destroys profitability slowly without ever triggering a massive system alarm.
Yep, a traditional perimeter defense cannot catch that. Security must be embedded simultaneously across the raw data, the models, the agent applications, and the physical hardware.
That sounds incredibly complex.
It is. And the only viable defense against an AI operating at machine speed is to deploy your own AI agents to detect and neutralize those anomalies in real time.
So we are essentially talking about an invisible silicon-on-silicon arms race happening in the background while robotic forklifts just move boxes.
That's the reality of the modern factory.
Wow. Okay, when you aggregate all of this, the incredible velocity of adoption, the necessity of rebuilding legacy processes, the astronomical computing costs, and these machine speed cyber threats, how does a business leader actually chart a path forward?
Well, the Deloitte report distills the success of leading organizations down to 3 distinct operational patterns. First, successful companies anchor their AI strategy in core business problems, not the novelty of the technology.
Right.
Both Broadcom and UiPath emphasized that attacking your most significant operational bottleneck is the only way to generate a meaningful return on the massive capital required for these deployments.
Okay, focus on the business need first. What's the second pattern?
Second, they prioritize forward momentum over perfect planning. The CIO of Western Digital observed that they would much rather launch small pilots and fail fast than wait to design the perfect system and miss the technological wave entirely.
Because, as we established earlier, if you wait for perfection, the map has already redrawn itself.
Exactly. And finally, the organizations breaking out of pilot purgatory treat transformation as a permanent state of operation. Coca-Cola's leadership described their internal shift as moving from asking, what can we do with this technology, to demanding, what should we do to transform our business? That elevation in strategic thinking is the dividing line between merely experimenting with digital tools and achieving massive physical operational impact.
It requires a real willingness to dismantle the systems that made you successful in the past, knowing that the rules of the floor have fundamentally changed.
Absolutely.
Which leads to a final thought for you to mull over as you go about your day. We've gone from the explosive speed of AI adoption to physical robots in warehouses, down to the hidden costs and cyber threats. But if the half-life of technological relevance has truly shrunk to mere months, and physical goods are increasingly being assembled, sorted, and transported by autonomous agents sharing a collective hive mind intelligence, how long will it be until the physical products you buy in a store are entirely conceived, designed, manufactured, and shipped by a continuous loop of silicon-based workers?
It's a big question.
And in a world where absolute precision and maximum efficiency are guaranteed by machines, what becomes the true premium value of a human touch?
Every industry and every professional is going to have to answer that question much sooner than they think.
Thank you for joining us on this deep dive. Until next time, keep questioning the world around you.